Welcome in our class, grade 8. Let's recall the polynomial by joinmyquiz.com. So let's play a game. Let's type the code 895760, then enter game. Alright, so let's start. So let's wait first to start the game. Alright. So first question, you have to identify if that is polynomial or not. Square root of x plus 2. So I click no. Next question, x raised to negative 4. And that is no. Third question, 3c squared plus 2c. So I click yes. Then 2d, is that yes or no? So I click yes. And next, x plus 3. Alright, so that's the last questions. Now, I have here the questions. Were you able to identify each expressions? So answer is yes. How did you classify a polynomial from not a polynomial? A polynomial has a positive exponent and no radical sign. A not polynomial has a negative exponent, has a radical sign. So when you combine the two polynomials by dividing, then we can express the rational algebraic expression. This is our topic for today, Quarter 1, Module 3, Illustrating Rational Algebraic Expressions. After going through this module, you are expected to define rational algebraic expressions, identify rational algebraic expressions, evaluate rational algebraic expressions, and relate rational algebraic expressions in real-life situations. A rational algebraic expression is an expression that can be written in the form P over Q, where P and Q are polynomials and Q must not be equal to 0. Take note that Q not equal to 0. The expression must be in a fraction form. The expression must have in its numerator and denominator a constant, a variable, or a combinations of both that are polynomial expressions. The expression must not have a negative exponent, a radical sign, or a fraction exponent in the variables in both numerator and denominator. So that is the rational algebraic expression. Let's identify if that is rational or not irrational algebraic expressions. This title is irrational algebraic expressions or not. First one, 6 over x minus 3. That is rational algebraic expressions. Second, 2x raised to negative 2 minus 3 over 5 square root of x. Is that irrational? Not irrational algebraic expressions because of the square root, and we have an exponent which is negative 2. Next, 18n plus 1 over n squared plus n negative 2. Is that irrational? Yes, that is rational algebraic expressions. Next, 5x squared plus 6x negative 11 over 1. That is rational algebraic expression. 3x negative square root of y over x plus 6. That is not a rational algebraic expressions. Why? Because of the square root of y. 3x negative square root of y over 5 square root of x. That is not a rational algebraic expression just because of the square root. Now let's go on to the next slide. In rational algebraic expressions, you need to pay attention to what values of the variables that will make the denominator equal to 0. These values are called excluded values. These are the values that you cannot use because the denominator will become 0, and that is undefined. Let's have the example. So let's focus in denominator. S minus 3 equals 0, so let's set first into 0. And then apply the property of equality, which is addition. That is x equals to 3. That is the result. And then let's check. 6 over 3 minus 3. This 3 is substitute. We have the value for x, which is 3. Then substitute that into x. So 3 minus 3. That is becomes 0. So thus is 6 over 0. Another one. Let's focus to this one in denominator. Then let's apply this equation, which is a general trinomial. Let's factor. And we have this quantity n plus 2 quantity n minus 1 equals 0. Then let's use the property of equality. Then we got n equals negative 2 and that n equals to 1. Then let's check. So when you substitute 2, which is negative 2 to n, 18 times negative 2 plus 1, then same here, which is we have n squared plus n. Negative 2 squared, negative 2, then copy negative 2. Then the result is negative 35 over 0. Same here, just substitute 1. And then the result is 19 over 0. So it means this yellow answer, they are the excluded values, which are you cannot use because the denominator will become 0. Let's evaluate the expressions here. Let's have the first example, y squared negative 1 over y cubed negative 3. Again, do not use the excluded values to make denominator will not become 0. So I use rather y equals to 2. Then let's substitute. Let's substitute 2 to y. That becomes 2 squared negative 1 over 2 cubed negative 3. Then here, we have to simplify. 2 times 2 is 4. 2 times 2 times 2 is 8. Then simplify again. 4 minus 1, 8 minus 3. That is 3 over 5. Another example, 5x squared plus 6x negative 11 over 1. So let's use the x equals to 2. Again, do not use excluded values. We have to substitute 2 into x. And then next, you have to simplify. 2 times 2 is 4. Then just copy. And then 5 times 4 is 6 times 2. And then we have this. 5 times 4 is 20. 6 times is 12. Then simplify it again. We got 21. Actually, that's 21 over 1. Then you have to divide it and simplify it. Final your answer. That is 21. Last one is 6 over x minus 3. Let's use again x equals to 2. Substitute 2 into x. Then we have this. And then simplify 6 over 2 minus 3. 6 over negative 1. Again, this is the integers. 2 minus 3. You have to subtract and copy the sign of the higher number, which is negative 1. Then simplify it again. 6 over negative 1 is negative 6. Now let's apply the rational algebra expressions in real-life situation. Vanessa can finish writing a module in X hours, while his brother Ryan can finish writing the same module in Y hours. Write an expression that will illustrate their rate of work to finish writing the module. So let's have the table first, and that is a time in hours, and that is a part of work over hour. So let's write Vanessa first, and that's Vanessa represent for X hours, and Ryan is represent for Y hours. Then part of work is we have 1 hour. So let's write first 1 over x. And also here, 1 over y. So that is representing. Another problem, the area of rectangle is quantity x squared negative 121 square units, while its width measures quantity x plus 11 units. Illustrate the rational algebra expression in finding the length of the rectangle. So take note, we have the formula of the area of the rectangle, that is length times width. Since we need to find the length, therefore we have to equate the formula by dividing this in with both sides, and we get a new formula which is length equals area rectangle over width. And then let's substitute area rectangle, which is x squared negative 121, and then width, that is x plus 11. So that's the answer. Do you have any questions? If there's no question, now it's your turn to do this. Now help me to find the excluded values inside my house that will make the given expressions undefined. The first one is 6x over 2x minus 4. I give you a second to find out which are the excluded values. Alright, so let's see. Again, to identify the excluded values, we have to make sure focus into x minus 4, which is denominator. 2x negative 4, then let's find the GCF first. And then we have x minus 2 equals 0. Then the excluded values is 2. Let's check it out by substitute, and then it becomes 12 over 0. Alright, so let's have the number 2. So I give you other seconds too. Okay, let's identify. You have x squared negative 1. Then let's factor. Then we have 1 and negative 1. These are the excluded values from the house. Alright, so let's check it out by substitution. Then we have negative 1 over 0. I use the 1. You can use also negative 1, but I rather use the 1 also. Next, number 3, another 1. Alright, so let's see x squared negative 5x plus 6 to identify the excluded values. Then let's do the factoring. Then our excluded values is 3 and 2. And then let's check by substitution. I use 3. You can check also the 2. And then we have 21 over 0. Alright, so that's our excluded values from the house. Hi, thank you for coming. Is this your first vaccine or a second vaccine? Please fall in line for what you prefer. Pfizer in the first line, Moderna is in the second line. Know your value. Evaluate the rational algebra expressions. First line, where y equals 2. And the second line, where x equals to 1. These are the problem. Now I give only seconds to solve first the first line. Alright, so let's do the first line. Substitute. 2 into y. And we have 2 squared, then 4 times 2 plus 1 over 2 squared negative 1. Then simplify it. 4 plus 8 plus 1 over 4 minus 1. Where do we get the 4 and 8? 2 times 2 is 4, then 4 times 2 is 8. Then 2 times 2 here is 4. Simplify, we have 13 over 3. And next here, I give you again the seconds to answer the 5x over 3x negative 9. Alright, so let's see. Substitute 1 into x. 5 times 1 over 3 times 1 minus 9. And then we have 5 over 3 minus 9. And then we have 5 over negative 6. So this one you have to subtract according to the integers. Then copy the signs of the higher number. Alright, so that's it. Next one is represent me. Now how I represent you. Represent the given phrases and statements into rational algebraic expressions. The first one is the sum of 3 and 2 of a number n divided by the sum of thrice a number n and 7. I give you again the seconds to answer this. Alright, so let's reveal the answer. That's 3 plus 2n over 3n plus 7. Next, number 2. Miggy can complete his school math reviewer in 3 hours. What part of the work can be completed by Miggy after 4 hours? I give you again the second to represent this given. Alright, so let's see. We have 4 over t. Great job! So we're done in module 3. See you next meeting, grade 8. Bye-bye.